Welcome to DevHour. My name is Heath Naylor. I'm going to sort of moderate this, pose some questions, but it's an open format. So anytime you guys want to crosstalk, talk about a topic, introduce a topic, go for it. We're going to go ahead and go around the room and just have you guys introduce yourselves. Starting with you.
Oh, we're going clockwise, so I'm not last.
I told you clockwise.
I'm Kevin Owocki. I'm the founder of Gitcoin, which is not a token. It is a live D-app, which basically allows you to put a bounty on any open source software issue. So basically solving the incentivization problems associated with open source software. We've done about 350 bounties in the last 6 months since we launched and have facilitated 4 full-time hires through the platform. So pretty long on Ethereum and the future of work being on the blockchain. I think that there will be open source jobs on open source money. Thank you very much for having me.
Absolutely. Thanks for coming.
My name is Coury. I work for Opolis, which is a HR and employment tech company that's looking into the blockchain space to help solve some incentivization problems in the recruiting and employment area. And I work with Nick here. Also help run the Ethereum Denver and Rocky Mountain blockchain meetups in Denver, and the ETH Denver hackathon. Open source developer. Yeah.
Nice.
My name is Nick Miller. Like Coury mentioned, we're both at Opolis. I've been involved with Bitcoin and crypto in general for almost 2 years now, but I've only been working in it for about 6 months. I was previously at Qtum, which is a hardware wallet manufacturer, and then Coury introduced me to Opolis, and so I'm helping out with that project now. Mostly focused on Bitcoin, but I do find a lot of value in Ethereum, and been having a lot of fun working on it.
I'm Matt Lewis. I've been doing Ruby on Rails and React development at Gusto for just over a year now. We do payroll, benefits, and HR software for small businesses. And on the side, I've been working on open source projects, getting outside, and I built my first Ethereum app in the ETH Denver hackathon recently.
Cool.
Nice.
So I'm Jordan Earls. I work for Qtum. I'm the lead developer and co-founder. And Qtum is basically like a platform, a smart contract blockchain platform that's independent and uses like the whole Bitcoin style transactions with Ethereum virtual machines, so you can write Solidity smart contracts on it and such. And it's proof of stake. And thanks for having me here.
Yeah, thanks for coming.
And I'll close it out. I'm Nick Stocchero. I work for a company called Miner and Kasch out of Maryland. We do big data consulting. And in my spare time, have picked up a few Ethereum D-app development and just interested in the space. Been a Bitcoin investor since 2012.
That sounds like it worked out well for you.
It's been interesting.
Yeah, awesome. So going around the room, it's a lot of Ethereum is represented here, and then we've got Qtum, which is sort of tied into the Ethereum ecosystem with EVM, and we'll get more into that later. But then there's Bitcoin, Qtum, EOS, IOTA, Neo, and so many more. What's going on? Like, what's going to win? Why are all of these blockchains out there? What's the value in them?
Gitcoin's going to win.
It's Bitcoin all the way.
No, I think Gitcoin is one of the, not to like derail it from your blockchain question, but that's one of the dApps that's like apparently like very obviously useful.
Right, and that's the thing is when we're looking at the decentralized applications, I'm way more interested in things that are working on a blockchain. It's helpful if it's popular, which means it's got a lot of nodes, it's got a lot of sort of security for the proof of work concept. But that it actually does something and is providing value in some way.
Yeah.
Way less interested in the crypto economics, investing, and that side of things. So.
Yeah, well, it's going to be hard to answer your question about those blockchains.
Right.
But basically, so like Coury and Nick, I'm one of the community organizers in the Colorado scene out here, and my niche is Boulder Startup Week and the Boulder Blockchain Meetup Group. And in the beginner circle of the Boulder Blockchain group, that's actually one of the things that we cover. So basically, there's different value propositions for different categories of blockchain. So Bitcoin's the OG. It's kind of fallen into a store of value type space with respect to other blockchains, and it's kind of the base exchange currency for a lot of the other currencies that you can trade in and out of. I think that smart contracts is clearly another category of value that you'll see in blockchain applications. So Ethereum is the largest market cap smart contract platform, followed by EOS, and there's a long tail of other projects that are doing smart contract stuff. And then there's privacy coins, so basically blockchains, but with zero knowledge proof or ring signatures or stuff like that. So the idea is to have worldwide money that's as private as Kasch would be with those. And then I think arguably governance is a fourth category that you see within the blockchains that sort of separates them from each other. So Decred, as far as I know, is the leader in that space. Those are kind of like the taxonomy that I think about when I think about how comparing the top cryptocurrencies to each other are kind of like apples to oranges. So you can't just say one's better than another because they each have specific use cases they're better at.
Right. And so Qtum has the governance idea on the blockchain as well.
Yeah.
Yeah. Can you talk about that?
Yeah, so, I mean, for the way Qtum's governance system works, like that's on the blockchain, it's called Decentralized Governance Protocol, or DGP. We have a lot of acronyms, by the way. But, basically we designed it so that people can come together and change like small parameters. It doesn't really replace like, doing a hard fork or anything like that. But it does replace like this 2-year-long argument that Bitcoin has had over what the block size should be. So in Qtum, you can like basically governing parties can come together and say, okay, this block size is too small or whatever, and vote for it to be larger or smaller. And if the proposal passes and everything and gets enough votes, then it automatically becomes active. There's no new software to download, no disruption to the ecosystem. And that's kind of like what was designed for, was more for like adapting to scaling and also adapting to like, if there's an attack or something like that. But also, I mean, the whole concept, like we're kind of trying to take it a little bit further than just, okay, this is what controls our blockchain, and actually try and take it to where we have this piece that you can actually tie into your smart contracts and decentralized apps, so that, because decentralized apps usually have some kind of owner or something and some kind of centralization aspect to it. And you need governance to kind of assist with that and, adapt to the outside world of, okay, your company got bought out by Microsoft. You don't want to do some disruptive move where everyone has to use some new smart contract or whatever. You just want it to work and all your customers to be unaffected by it.
Sort of hand over the ownership.
Yeah.
In that scenario.
So, I mean, like it can hand over ownership or change parameters or whatever. So, like, adapt to scaling and that kind of thing.
Sure. That makes sense. One of the things while I was learning about Ethereum in particular was this confusion around gas. And I didn't fully understand when gas becomes ether and does ether become gas. Where is that value used as it's allocated to the bytecode? Does anybody know the internals of that system?
Kind of.
A lot. The guy who's put EVM on another blockchain.
Yeah.
Well, so the interesting thing is Qtum doesn't use gas, does it?
Yes. It uses gas. You have
Okay.
to pay Qtum for gas.
Okay.
That's like kind of the whole core utility.
Right.
It was to convert it into gas that's good for one transaction or whatever and get a refund. But the whole concept behind gas is basically, okay, say you have a naive blockchain and you have a Turing complete virtual machine. You can write an infinite loop. So someone does that. Now your blockchain is stopped. What do you do to fix it? So gas is kind of like it's not a perfect solution, but it's a solution to actually fix that problem and make it to where everything has a defined point of finishing, like every program that will execute on the blockchain.
Yeah, so for example, in that, you've got contracts and they've got a gas limit associated with them.
Yeah.
Right?
Not the contract.
Well, not the
specifically,
contract, but the
the
transactions.
Transactions.
Yeah.
Yeah, so when you submit a transaction, you're saying, I expect it to take up to this amount of gas.
Yeah.
And then that's just a unit, and then you attach ether value to each one of those units. So you're saying if it takes 1,000 gas and I pay 0.00001 ETH or whatever per unit of gas, you multiply those together, that's up to the amount you're going to pay. And it solves the halting problem.
Yeah, the halting
specifically.
problem.
Yeah, if you look at any arbitrary program, you can't tell if it's going to stop or not in a
Right.
generalized way. So if the Ethereum network just let you run your transaction forever, you could very easily DDoS or
Right.
denial of service the
So
network.
it's really just economically decentralizing that behavior. You have to pay a lot to tie up the network.
Yeah,
Exactly.
Yeah.
And even at a certain point, a single block has a maximum allowable gas limit, which in Ethereum, as different from Bitcoin, which uses like megabytes and data size, Ethereum uses just the amount of gas. And so you could actually fill up, like one block could use the same amount of gas as another, but be different in kilobytes or megabytes just because you're using some data that costs the same amount of gas, but it's like bigger.
Right.
Yeah.
So I guess the systems that are running this transaction and utilizing that gas, are these validators? Are these miners? What are those?
Yes and yes.
Yes and yes. So what's their reward? Do they get a portion of that gas converted back to Ether as a transaction fee, or how does that relationship work?
It just gets added to the block reward,
Okay.
and they don't really see any. There's not any like complicated logistics. But yeah.
And in theory, like, the miners and stuff can refuse to accept like a contract that, or a transaction that doesn't pay at least, one Wii or whatever of like because there's like a gas price and the gas limit. So if they aren't paying enough gas price, then they can just refuse to mine it because it's inefficient or whatever.
Well, yeah, they've got other
They got other transactions to
contracts and
process.
transactions that are way more lucrative.
Yeah.
So the gas price is like, so that when something like CryptoKitties appears and starts tying up all these resources, I can still incentivize somebody to take on my transactions over all these other ones that are clogging up the network.
Yes,
Or
exactly.
market. Yeah.
And
Okay.
people do this during ICOs where you'll see, like, it was pretty crazy during some of these ICOs. Like
Yeah,
back
back
a year ago, like
2017.
Bancor, there was a guy who paid, or a person who paid $15,000 for just a single ICO transaction. He paid like an incredible amount of gas just to get first in line. He was willing to pay that much. And
Wow.
I mean, I think the people get kind of stuck up around the gas concept and like slightly complicated, but it's just it's a way to fix the halting problem and the infinite loop thing and basically DDoS attacks on the network. But it's also like you don't want to price your computation directly in Ether. You want to have this like buffer decoupling so you can have a market now. And yeah, you're defining like I'll pay this much Ether for one gas. It's like, and you can say I'll pay that much for doing some addition, basically, because the gas is always tied to some computation. That's
And
happening.
I suppose the idea between the conversion to gas is to say, I'm willing to pay this much right now, and no matter how long it takes us to execute, the price of Ether is fluctuating as that occurs, and they're not suffering the consequences
Yeah.
of that because they've converted to gas.
This feels kind of like AWS instances where they have those spot instances that you can say, I have this task. It's like a backlogged worker that just processes things and it eventually has to get done, but it's not time sensitive. And if you can get it for me below this price, I'll pay it. If you can't, just put it off.
Yeah,
Right.
yeah.
Yeah.
Speaking of AWS and time sensitivity, so one of the things that I've been mulling my brain about is, so we've been talking about gas and that's doing a transaction on the blockchain. The converse is just reading off the blockchain. I was surprised when I was, starting with this that you can read stuff off the blockchain for free.
If you couldn't, it
Yeah.
wouldn't
Yeah.
work.
Yeah.
Because everyone has to be able to download
Yeah.
the blockchain from each other.
And really, you're only putting yourself at a disadvantage. You're going against your own hard drive, right? I mean,
Not
if you're a
necessarily.
full node.
If you're running your own node, but if you're calling out to another node, which is what most people do,
Yeah.
Right?
like when you're using MetaMask in your which is a
Right.
wallet in your
Yeah.
browser, you're hitting Infura, which is kind of the, I don't know what you describe it like, not the AWS of Ethereum, but
They have like specialized full nodes.
yeah, they're just like load balanced thousands of nodes.
Yeah.
As a service.
But
In
you're
the ideal
reading.
case, you're running your own full node.
Yeah.
So just by definition of having to download those blocks and validate them.
Yeah.
Yeah, you can just read it.
Yeah, but whether you have your own node or you're kind of leveraging someone else's node, are there any? I've been like, there has to be some like feature that, or some sort of like something you can do where reading is like, I'm thinking like a CDN. I'm thinking of like S3, where you have some writes are expensive, or you have to do them. But are there any like leveraging that concept of I can now read stuff for free? Are there any like ideas that anyone's had to like leverage that?
Like in the way that you've got like a big file or something and you want to make it available if people pay you for the bandwidth for it.
Exactly, or like like hosting websites. Like I pay.
Isn't that kind of what was it, Filecoin or something like that? It was kind of trying to do.
Filecoin,
Yeah.
SIA Coin.
Yeah.
Storage is up
Yeah.
there too.
Storage, yeah.
Do you,
Oh, are you talking about reading data still, or are you just talking about storing data? Like, you could, incentivizing the storage of data, so you can guarantee like this data is going to be stored for X amount of time if you pay X amount of dollars on a decentralized network.
I guess I'm not very sure. The thing I'm thinking of is like there are major like S3 is huge.
Yeah.
Dropbox, think of Google Drive, all the things that are storing things, and people are paying to store things. And I'm streaming. It's like Spotify streaming music. Like it's instead of like having all these servers where you're paying S3, like why not leverage a decentralized sort of network?
Yeah.
That is sort of what all those like SIA Cohen and Filecoin and storage are all trying to say. I've got a terabyte of hard drive space. I want to rent it out, and then they figure out somebody is going to pay to encrypt their files and then put them on 5 other people's devices.
Yeah.
And the interesting part is like if I'm getting paid for it, what is my incentive to like keep my hard drive online? Why wouldn't I just take the money?
Mm-hmm.
Right.
And they have like this weird reward system where you have to put X amount of dollars in.
The stakes
When
system.
you put your stuff up for 99% uptime, you eventually get to pull the money back out. But a lot of this can be smart contracted, which is really interesting.
Bonding, kind of bond systems and staking.
Yeah.
Yeah.
And it seems like a lot of them are trying to take over some of the AWS space, which is really strong, really encrypted data that's highly available, but cheaper and decentralized.
Mm-hmm. Yeah.
Well, and it's adding a second layer. So like when you're talking about data on the blockchain, like one of the issues is you can't store everything on blockchain, because then you run into what's called blockchain bloat, where you're sooner or later you have say terabyte blocks.
Yeah.
It's like then you're just then people aren't able to run those nodes and actually validate that data.
Yeah.
So usually what people will do in some cases is put kind of cryptographic links to other data off chain. Well, they'll store some hash of that data on chain.
Yeah.
And then you can validate that that data is in fact legitimate, and it
Yeah.
has that integrity because you have the hash on chain that everyone can see.
Yeah.
But the data is stored off chain. You can always validate that it's the same.
Yeah.
Interesting.
Huh.
I think people have been doing that with DApps that are written in Ethereum and run on the blockchain in Ethereum, but then connect to assets like user avatars on IPFS.
It's exactly what we're doing. Yeah, we aren't. It's kind of weird writing an app like where IPFS and Ethereum are our back end, and it's an entirely a single page application. That's you just send the HTML and JavaScript to someone, and they can use the application.
Right.
And there's no way it's going to get shut down. And that's kind of the whole Web3 philosophy. And you see it echoed in popular media now through like shows like Silicon Valley, which is really cool to see that this kind of decentralized, peer-to-peer, tamper-proof, censorship-resistant internet, like this original vision that was, came around in the cypherpunk era decades ago, is now actually like being brought to fruition.
I feel like it's been building for a long time,
Yeah.
just through all the protocols. Like, you're just going back to, torrenting.
Yeah.
It's like when that first came out, I was like, things are changing.
There's no way anyone can shut this down.
Yeah.
Whoa, that's crazy.
Even when it was like peer-to-peer, like DC++ and Kazaa stuff.
Yeah.
Like people are just sharing because it's default on. Like toggle is on.
Yep.
Opt out.
Leech. You
Okay, so to sort of switch the topic, another thing I ran across when looking at these were this concept of pump and dump, which is highly regulated, well, somewhat regulated in traditional economics. But in blockchain, it's like the wild, wild west. People are pumping and dumping all over the place. What are your thoughts on that? And anybody not familiar is where you all buy in on a coin at the same time and sell high to try to get as much profit while everybody else who's not part of the scheme is suffering, essentially.
Kevin.
Yeah.
I mean, so I think that so I'm going to answer your question in a roundabout way and say that before you can talk about what's wrong in the current ecosystem, which I think pump and dump is clearly an example of, we need to sort of set the stage of why all this matters. Why does gas matter? Why does the decentralized storage matter? And I think that people are really excited about a truly decentralized internet that takes the power from the center and moves it to the edges. So if you think about the economic value of Facebook and Google and Airbnb and all these other applications and how much wealth has accumulated in Silicon Valley and Wall Street because of that, and you think about taking that kind of value and taking it out of this regulated financial ecosystem and giving it back to the people and moving the power to the edges to places like Colorado, then clearly there's a ton of financial upside to that. So, but that financial upside, which I think we all sort of realize is there, is very hypothetical. And in the traditional stock market, you have equations for evaluating securities on earnings, and with blockchain, everything's very abstract, and there's no solid way of valuing a specific coin according to any solid tried and true economic principle. And because of that, you have bad actors. Well, because of that, and also the fact that this is worldwide and the jurisdiction isn't clear, and also people can be anonymous in the system, then you get bad actors who are doing pump and dump schemes, basically trying to draw in dumb money and into their coins and then dump at the top and then basically
Profit.
and just basically profit, and no one knows who they are, and there's no accountability in that. So I mean, I think that hopefully as and all of this is like, it's like, there's this quote in Battlestar Galactica. I don't know if anyone else is a sci-fi fan here, but all of this has happened before, and all of it'll happen again. I mean, the traditional financial system had pump and dumps before the antibodies evolved for those viruses in the system, and we're just very in this new ecosystem where no one's figured out how to curb pump and dumps yet. But as the ecosystem evolves, then we'll develop antibodies to it.
Do you think that'll become a protocol feature where the pump and dump is decentralized by something within the protocol, or is it self-governance among the community?
I don't think it's possible.
Right.
You're talking about, it's really hard to regulate and control open systems. So you see spam on the internet, you see a ton of there's just a lot of Nigerian princes out there. And we've all learned what the Nigerian prince is, and we'll all learn hopefully what the pump. Yeah, but there's always going to be people on the edges. But like the pump and dumps are the spam, they're the fake news of the crypto world right now. And people just have to learn, and it's just kind of it's the Wild West.
It's the social awareness around the problem.
It's just part of the process.
I think it's interesting because there are protections for individual investors today. I can't just go out and throw money at options or margin investing or Forex or anything. I have to know enough to find a broker to do it on my behalf, and then I have to pay them fees. And one of the nice things about these markets, like crypto, is that I can do it on my own. I don't have to pay anybody fees, and they're designed in a way that I won't have to. But the protections in how much I can put in and how much of my own money I can lose are also not there either. Mm-hmm. And there are arguments both ways as to individual freedom or individual protection. Once you pass a certain dollar amount, you can just do as much investment as you want, which is a little strange, right? That specific rule and the regulations behind Wall Street markets are sort of in a way that if you have enough money, you can do it, but if you don't, we have arbitrary rules that may or may not help you, or maybe they just disincentivize enough that average Joes don't want to get in.
Right.
Maybe that's a good thing.
Yeah.
It's hard. There's a lot of people who want to do
Yeah.
institutional investing and can't, and then there's a lot of people who would definitely get scammed into it who it's harder to get them now.
Right.
It's really sad though. I mean, I remember when BitConnect collapsed, which is, if anyone's not in the bubble of the ecosystem, that's one of the projects that just collapsed when the regulators got involved, and it was really sad. Like, there was YouTube videos coming out of people who, like, their family member was sick and they heard that they could make 100x on BitConnect so they could pay for the medical fees, and they just lost everything. And it's really sad to see that. So I don't know what the antibodies look like in a decentralized ecosystem, but I hope that they start developing quickly.
Mm-hmm. Yeah, because especially when there are vulnerable people that are getting into this without full knowledge, without awareness, and they're the ones suffering. It's not, their money literally was essentially stolen at that point. So, yeah, I agree. Antibodies would be a good thing within our community. And I think outreach is important for that, and just letting people, laying the groundwork for them as they get into it.
I think a lot of it is education. Like, you can still get your money taken by somebody with a financial advisor certification. But the more you look online, like, the first thing you'll Google will be, this is probably a scam. This person is doing a thing that's scammy.
And I think that, well, in a financial advisor situation, I mean, you might not have a financial advisor that has your best interests at heart, but at worst, you're going to make 4% per year instead of 6% or something like that because they're getting some sort of kickback. In cryptocurrency, it's crazy because you can go up 10x or you can also go down 10x with your investment. So it's just way more risky.
Do you think the number one, it's early, so you kind of expect that, but number two, the kind of, we've all, I think, used the term dollars. Do you think that, like, because there's not a tangible market yet for cryptos, like, there's shops that'll take it, but, like, most of the pump and dump is valuable because you swap it to US dollars. Do you think that's a kind of a future state where, like, it's not so much of you can't fluctuate it so much because there's more you can do with the currencies, or there's less of them? Like, without the antibodies, like, what's, like, the natural progression as crypto grows?
Well, I think that as more money gets into the system and the market cap goes up, like, you have more liquidity, like, volatility will reduce over time. So that will help, at least for the major players, right? Because they're the ones that people are actually putting a lot of money into. Yeah. I don't know if we'll ever get away from the volatility of kind of the smaller players as more and more blockchains come into existence.
I'm really interested in projects like Maker, because there have been a couple of projects to build a stable coin, something that pegs 1-to-1 with any given fiat exchange rate. Like, it's usually the US dollar. Tether's out there, and there's a lot of question as to whether the company backing Tether with US dollars has the US dollars to actually be solvent. But Maker was really interesting when I spoke to them. They have this system in which they incentivize people putting liquidity into the system in exchange for interest on their loans to the system, and then if the value of this currency starts to collapse, they start liquidating the loans to stabilize the price. And
stable coins are, like, some kind of stability on the blockchain is absolutely vital, which I'm sure Kevin can talk about, because he just introduced Maker's platform onto Gitcoin, and
cool.
They were having problems. You guys were dealing with the volatility in Ethereum a few months ago when you post up a issue for a GitHub repo, and someone put a couple ETH in there, and then all of a sudden it was worth half as much, and no one would work on it. And it's really difficult to do business without stability. I think as far as pump and dumps go, we're just going to see the space mature. There's going to be a lot less volatility. The news around, how all the gains in 10x, 100x that's happening, that's going to die down in the coming years, because that's just not going to happen as much as more money comes in, and people will be less susceptible, less kind of dollar signs in their eyes, in the common Joe's eyes, and it will become more. It's commonly known that the days of 10xing or 100xing are over, and be weary of anyone claiming that you're going to get something.
More of a utility blockchain that just happens to carry value kind of thing.
Yeah, I mean, the prices will just stabilize, and then I'm not
Hopefully.
going to say, I'm not going to say there's going to be, like, clear, winners in the blockchain, and it will just be them forever, and new ones won't come up and kind of replace them, but it will be much more rare.
Infrequent.
Yeah.
Makes sense. What are some other sort of areas for growth or some pain points of blockchains and smart contracts right now?
Privacy.
I mean,
that's-
too much privacy, not enough privacy.
Not enough. Like in the smart contract world, we're dealing with dealing with people's salaries and benefits in Opolis, and we've have to look into some ways to obfuscate that, but still utilize kind of the trust minimization of the blockchain, and it's a really hard problem, especially on Ethereum.
Public bank accounts are a weird thing. If I pay you one transaction, I can look at your account and see how much.
Yeah.
One thing I think is missing, and actually just authored an EIP, which is an Ethereum improvement proposal for this, is subscriptions on the blockchain. So I think that subscriptions are something that's working in the legacy world in terms of monetization, especially relative to surveillance capitalism ad models. So, with Adobe Creative Cloud, I pay them $30 a month and I get access to Illustrator and Photoshop and whatever else is in their package, and I can cancel at any time, and there's aligned incentives because it's software as a service, and I use it and I cancel if I don't. Whereas right now, the monetization model for a lot of these apps is this like Byzantine token ICO thing, and there's all these rules around vesting schedules, and is it a security, is it not a security, is it a Chuck E. Cheese token, like no one really knows. It can be a token, a utility token, then become a security, you can go back to a utility token. It's just like very confusing, and I think that in order to get more adoption, that we need to introduce things like subscriptions would be a way more healthy way for dApps to align their incentives with their users than an ICO. So that's one that I'm proposing to start becoming a standard in the Ethereum space. And the more money is moving around and people are able to support their dev teams off of crypto in a way that's sustainable, then I think that helps the ecosystem grow.
Yeah, definitely.
Does that it feels like that sort of aligns with the ideas behind on-chain governance, like this idea that I can vote for things I care about, and for people I trust, I can tell them to vote for me and have them vote on my behalf.
Yeah.
And build this system where we vote for things we want. The general democratic will is seen. Are there things that align in that space?
Yeah, I mean, there's a bunch of people doing decentralized autonomous organizations, and I think in a way what Opolis is building and what Gitcoin is building are part of decentralized autonomous organizations. Aragon, DAOstack, and a few other people are building what I consider to be the harder part of that, which is how do you make decision making and how do you do democracy on chain. I mean, I'm just matching you with developers, which to me is a way simpler use case, and so I think there's a lot of components to be built there. And that's one of them.
Well, and so that's an interesting concept. So you're matching to developers, and you support GitHub as your sole interface for that right now, right?
Mm-hmm.
So that's tied to an account that's generally a person. And so you know who's working on the work and you know who's proposed the work. So I feel like that's keeping some level of honesty, just knowing each other.
Yeah, so basically Gitcoin is a way of putting a bounty on any issue in open source. So GitHub does the collaboration layer and we do the incentivization layer on top of that. And people always ask me, well, how do I know that someone's going to pay me out after I do the work? And, this is all supposed to be trustless. And, I think in the long term, we're going to have arbitration and governance in order to arbitrate disputes. But in the near term, everything's connected to your GitHub username. And also, people generally aren't mean to each other in open source software.
Yeah.
So we have that going for us in the short term. And it's really in GitHub, anyone can make a username and they can be anonymous.
Sure.
I can make my username foobar123. And
It's also pretty easy to see if they're credible to work on the work, though. You look at their account and you're like, no.
Yeah.
They created their account 2 weeks ago.
Yeah.
But then they write code, you look at their code, it looks good. There you go.
Yeah, I mean, as long as it's functional programming, then
As long as there's type annotations, we're good.
Well, I'm taking the inverse relationship, the person doing the work and wanting to get paid.
Mm-hmm.
If the person who created the issue is just looking for arbitrary work, they have a really short-lived account. I think it goes back to that antibody system. You've got to be aware,
Yeah.
am I willing to do work for this person?
I mean, reputation systems on these identity and reputation on the blockchain is super important right now. A lot of identity on the internet is like Facebook and Google.
This should have been the first answer to your question of what's missing in the decentralized space. Identity and reputation is going to be really huge.
Yeah,
and
privacy is a part of that as well.
Yeah, for sure.
When to expose what information, when not to.
Exactly.
Yeah.
Very, very hard problems. Like blockchain was a very hard problem that was solved in a quite elegant way as kind of a base layer for these, this tamper-proof decentralized database. But all of the things that we need to build on top of it involve a lot more human interactions, and it's going to be.
That's where it gets messy.
It's going to be an interesting couple of years ahead of us.
The one you mentioned it was really interesting was arbitration, because I can sign a contract with anybody here and then know that's going to work out because I'll take it to court and to a single person who's a judge, and they'll figure it out if it doesn't work out. But how do you make that work in a world where kind of your voting power, as we know it now, is a lot of the time tied to how much money you have, right?
It doesn't have to be that way.
It depends on how you design the incentive system.
I think the identity is the key thing. Figuring out who's a person and how votes get counted is really key to everything we want to do here.
Yeah.
So I'm in this category where I love beautiful interfaces and I love kumbaya community stuff, but when it comes to governance and game theory and all that kind of shit, I leave that to the smart people at Consensus. I'd
love
give
to
me
talk about AI and what kind of machine is controlling us right now.
I'm
sitting on my couch late at night.
But when it comes to building it, I'm give me an interface, give me 3 method calls that I can use to interface with your thing, and you figure all that shit out. So that's a long way of saying I don't know the answer to your question, but we're built on top of standard bounties, which is a standard bounty interface on Ethereum, and they're building a whole game theoretic model for arbitration that'll make it easy for kumbaya community guys like me to integrate it.
It is fascinating to see these layers too, the idea that you could kind of just put these tech together, add ring signatures for privacy, add a governance layer, add something dealing with reputation or identity.
It's Unix philosophy for our money.
Yeah.
It's worked out well in the past. I think it'll work out well here as well. So one thing I want to sort of clear up, so Ethereum has this idea of an account, and your money is held in an account, and like you said, you can sort of see that visibly. Bitcoin has the UTXO, which is unspent transaction outputs, right? What's the opinions on those? Is there a winner? Is there a reason to do one over the other? Qtum uses UTXO and EVM, so it's sort of hybriding that system together.
So, just to give a quick overview of how Qtum works in that respect. So the EVM, of course, we kept mostly unmodified, so it still treats everything as if it's an account. It doesn't really know anything about the underlying blockchain, and that's kind of a good thing for the design. On the actual Qtum blockchain, that uses UTXOs like Bitcoin, and so that's you have change addresses, coins you receive can be either spent or unspent, and you have to send them back to yourself and all that complicated stuff. And all that stuff is really hard to try and create a contract around, because you can see that in some of the Bitcoin contracts or the smart contracts. Usually they're very clunky, very not easy to use at all, and there's no good way to make it better.
Just because
period.
Of, Bitcoin script and UTXOs. Because of UTXOs.
Yeah, because of the way it's either spent or unspent, and there is no in between. There's no state.
Yeah.
So
Qtum is abstracting.
So Qtum basically has an account abstraction layer that basically mediates all that. So the Ethereum virtual machine just knows it has a balance. It can send coins to addresses, and it can receive coins. That's all it needs to know. And that's what the account abstraction layer does, and then it will create transactions that are UTXO based on the account of the address, on the contract's behalf.
And what advantage is there in a kind of a smart contract platform to use UTXOs? Because one of the design decisions in Ethereum was man, this is going to be really hard. We'll just use this account model instead.
Yeah.
And that was a risk they took.
So one of the big advantages is the the whole SPV protocol for like mobile wallets and light wallets, like that already works with UTXOs. That's less clear on Ethereum. I think they do have like a prototype or alpha or something, but it's still very unstable. And but so we gain that advantage, and also UTXOs are a little bit more like potentially more scalable because of the being able to process them in parallel and that kind of thing. Their order is like inherent within the structure of the system. And then just the overall design, I feel like it's a little bit more clean because, you know, we can build these virtual machines and they can be ported to any blockchain platform, really. Like, as long as it has something that abstracts, like gives an account abstraction basically. So basically having the multiple virtual machines and everything working on this underlying more simple blockchain, I feel like is a big advantage.
Interesting. Cool.
But,
It's a very interesting approach, and it's like that's kind of why I love open source in general. Is you've got this that wouldn't have happened if the EVM wasn't open source, right? So you're working on the x86 VM as well.
Yeah.
But now you've got choice, so you can plug these in. And it doesn't have to be quantum. It can be any blockchain that somebody sees the value in for some reason, and they can go out and just start building this, which I think is beautiful.
Yeah.
And I love when people contribute. There's a ton of work and a ton of interest that goes into that, and then just to put it on the internet and say, okay, here you go, run with it as you wish.
And the cool thing, at least for us, is like the you know, we're building like a enterprise version of Qtum as well. So like for enterprises and these big companies and stuff to be able to come in, take our open source stuff and build their own virtual machine that suits exactly their business use cases for their accounting or whatever, and be able to basically just plug that in and then have this private blockchain that, you know, just works, and then also being able to also leverage like, you know, EVM based smart contracts on the side as well. Like I think that's like a big advantage to that, you know, enterprise use cases will have.
Cool. Let's talk about sidechains. What are some of the most popular sidechains, and what are sidechains even there for?
They're there for scaling, because right now you just can't put everything on these main chains. I mean, correct me if I'm wrong.
Can we do a term definition real quick?
Yeah.
Well, I guess before we specifically on sidechains, is it fair to say sharding is a form of?
I wouldn't be. I don't know. I don't think that would. It's.
Yeah, I don't know if I can give a specific definition of sidechains. I haven't spent too much time researching in them. I mean, I think the general idea is, you know, you've got, say in Bitcoin, right? You've got the main chain, but then let's say you do want to add a smart contract layer on top of Bitcoin that's more than just a stack-based machine that Bitcoin is and actually has Turing completeness. You could have a separate chain that then has a way of pegging one-to-one from Bitcoin into this virtual Bitcoin or whatever.
Leveraging the existing security.
Exactly, yeah. So then there's kind of these, I haven't done a whole lot of research on it, so if anyone knows, please correct me if I'm wrong, but there's some kind of cryptographic checkpoints along the way of validating that computation happened.
From the research I've done with sidechains, and would it be accurate to say the Lightning Network would be a sidechain for Bitcoin? Or isn't that,
no, the Lightning Network.
State channel.
Yeah, the Lightning Network is more of a state channel.
Okay. And so is Plasma for Ethereum.
Yeah, where really all you're doing is just passing Bitcoin transactions around, like through the internet, just off chain.
Okay.
And then you have game theoretic protections in there to keep that secure.
And a way to federal it all on chain.
Yeah. Conceptually, it's. I mean, at first glance, it's hard to know what is the difference between side chains and state channels. You hear the name Raiden and Lightning Round and Plasma and all these zappy things. What's even happening here? But it's all just trying to fit more onto the blockchain.
Right.
Yeah.
And
widen the pipe.
And sort of offload the work that's happening in these transactions on the blockchain to a different level. So you can operate there. You can still operate in a trustless environment with exit strategies, as they call them in Plasma, and Merkle tree verification and things along those lines. And then once you're done transacting between these channels with each other, you can close out and take that one transaction, that exit transaction, onto the blockchain. So you have two transactions, one to open the state channel, one to close it, and then however many that happened in there is totally unrepresented on the blockchain itself.
Could be
So
billions.
Right.
The best analogy that I've ever heard for state channels was by Alex Miller, the Grid Plus founder, and he basically had said that state channels are like when you go to the bar. Let's say you're going to Boulder Startup Week for the blockchain track because it's your favorite in Colorado. I can't show that with a straight face. But so basically the way it works is you're going to the blockchain happy hour on Thursday at Press Play, and you go to the bartender and you give him your credit card and you say, I want 4 Avalanche IPAs. And then he says, do you want to keep your tab open or do you want to close it? And you say, well, I want to keep it open because I want to keep accruing beers on my tab. And they want to keep it open because they don't have to pay 34 cents and 3% to the credit card company every time they swipe the card. And so you keep ordering for the rest of the night and then you close out at the end of the night. And A, you get the convenience of not having to sign every transaction, and B, the bar doesn't have to pay 30 cents transaction fee every single time. So it's a cheaper way of settling up off of the main network and then settling up at the end and doing one large settle up. And I think that's how he described, I forget what Grid Plus is doing. It's not exactly state channels. It's some more centralized version of all this stuff. But that to me was an approachable way of explaining it to someone who's not super in the blockchain level.
It's a bar tab, and the bar only has to go to the bank once as opposed for
well, and it's to facilitate the trustless. You've got on the input, you put in money, the max amount you're willing to spend during this encounter, and so does the party that's charging you. So if they misbehave, they're decentralized via that component at the higher level. I think there's no other, well, there are tons of ways to skin it, but you need to scale the platform, and this is definitely one that's heading, I think, in the right direction.
Yeah.
Because the transaction fees on Bitcoin got insane real quick. And so having Lightning Network or something in facilitation of reducing those is always good.
I mean, I personally, I think the transaction fees on all the networks are insane because they should be like really, really, really small.
Right.
If you want to have things like micropayments and
critical mass and mass adoption.
Not on the main chains per se,
Sure.
because to incentivize people to secure these kind of the root levels, and then we're abstracting and building on top of these things. But these are the ones that are going to be cheaper.
Well, and especially in Bitcoin's case, like, I'm sure anybody who's done research into Bitcoin has seen that there's this 21 million cap of coins that will be mined as part of the block reward. So when we get to that point, 2140 roughly, assuming Bitcoin is still around and being used as this global currency, you won't have block rewards anymore. So then the only thing incentivizing miners will be fees. So just by definition, fees will go up. But maybe it will cost $100 to open say a Lightning channel, but you're doing maybe 10,000 payments or micropayments over that $100, so you can amortize, and then your cost per transaction is virtually zero and extremely low.
I wonder if there's any, just thinking back to your subscription model, I wonder if there's any sort of way to include that in that solution. But I won't go, it's just off the top of my head. Let's move on from that. I want to get this before we have to end in 10-15 minutes. Proof of work versus proof of stake. I'm of the opinion that proof of stake, which is this idea of you putting your money forward to become a validator, I believe the term is, of that block, or I guess a miner of the block.
In proof of stake?
It depends.
Because I know Ethereum has a hybrid system, or is planning to with Casper.
They will implement a hybrid and then move into a full proof of stake.
Right.
Yeah.
So you're putting forward your money, and it's an exceptionally large amount of money that you would be decentralized to misbehave on the network. And now you have a much smaller pool of people who need to validate. So you're saving a ton of energy across the system. is that feasible? Does that work, or are we still way too early to even know versus proof of work?
Aren't you all
I
proof of
think it
stake?
works. Yeah, we're proof of stake,
Yeah, so
and we've been launched for a few months.
there's
It's
other
a big
blockchains
trend.
there's other blockchains that are proof of
Yeah.
stake that have been around for quite a while.
So I think one of the big things is that there's kind of two flavors of proof of stake right now. The more popular flavor is called delegated proof of stake, and that's basically where it's typically like there's a set number of validators that are allowed to create blocks. So like in Neo it's 7, and I think EOS is planned to be 20 or maybe 30. But so there's like a set number, and basically you have to usually have some kind of requirements, like you have to be holding so many coins, and if you don't stake or miss like more than so many blocks, then you can get kicked out. There might be a voting aspect to it, like where you have to be voted in by the community and people. I think Lisk I think actually does that, where you have like you take your coins and you can not send it to a pool, but you can like basically say this pool is allowed to use my coins for staking, and they'll give me some reward for it or whatever. So there's that kind of flavor. Where it's mainly like a certain set of people that are basically creating blocks and validating the protocol. The flavor that we use for Qtum is more Satoshi-like and free-for-all. So there's no cap on the number of validators. Anyone can validate with any amount of coins. There's actually like someone that staked a block a while back with like 0.4 Qtum, which is like, I think that was like 1 in 1,000 years kind of odds. But I don't know. But so they got really lucky. But either way, it like proves like the point of like, anyone can be staking. There's like a proportional like, if you're staking more coins, you can get more blocks, that kind of thing. But there's no cap and there's no requirement that you be staking or you like get kicked out or something like that.
I know one of the concerns in proof of work is these sort of mining pools where everybody's sort of pulling their resources against it, and the odd chance that somebody gets, now correct me if I'm wrong, gets the proof or the block generated, and then that gets distributed out to the pool. Wouldn't that same system happen with proof of stake, where everybody puts all their money in one place, and then you just bet big on the block, get that reward, and then filter it back out? Isn't that the same?
Yeah, I think
problem?
you'd be able to have staking pools, but it's not always. You're having at least in the Casper realm of which is the
Right, and that's
key
still proof of work
stake.
for the blocks.
Well, in Casper, is the proof of stake consensus model that Ethereum's been working on for years now, and little backstory, they aren't completely satisfied with the game theory behind delegated proof of stake and the other proof of stake models, and they've thought about some of these really hard to explain and hard to think about issues in proof of stake, like the long range attack and the nothing at stake problems. But I want to say there's randomness, and they're not just using one validators, but they're using validator sets. So from an attack
They're
perspective,
setting it up to be like compatible with sharding and everything too.
Yeah, that's
So
actually
like a whole
one of the
other
fascinating things
complicated
about-
thing.
Besides just the consensus and the security that proof of stake offers, there's this notion of transaction finality, which is really important for things like sharding and scaling the blockchain in the sharding model.
So what is sharding in terms of blockchain?
You're similar to a database. You're just kind of namespacing the addresses and splitting up the computation. And right now, all blockchains are single-threaded. Every single computer node running the blockchain has to run the same code to produce the same output and come at consensus. And now you can split everything up, and you can have this set of computers working on, say, every contract that address that starts with 1, and this set every contract address that starts with 2. So you namespace things, and then you can run things. You can run the blockchain concurrently, and you just get a lot more computation and transaction throughput that way. But you need transaction finality, which proof of work that is not offered by proof of work, which means that whenever you're going on an exchange and it says, you got to wait 6 blocks for your deposit to get confirmed, that's showing you that, there's no finality in it. Like, or after 6 blocks, we'll just consider it good.
Right.
But it's still like this possibility that there's a miner out there who's going to submit a longer chain, and then and it might not include your transaction, and it will just go away.
Yeah, in those cases, the blocks drop off and the transactions get processed on the longest chain at that point, right?
Yeah, exactly. Everyone switches to the longest chain, and there's a chance that some transactions in this other chain were not included in the other chain. And
to be fair, it's extremely unlikely,
Right.
Yeah.
given the current.
Yeah.
And
I know that
at least in
Bitcoin
Bitcoin, you can actually take those transactions and like rebroadcast them
Yeah.
onto the new
Right.
chain.
Totally, yeah, it's no problem. But like when you're dealing with these sharded, systems, you just can't have
Yeah, if you
that
get out of sync, it's
Right.
like
syncing issue.
exponentially.
Yeah.
It's on top
You
of
can't
each
have
other.
one shard know about another and question whether it's like the finality is good over here. It's, you just have to it just has to be final.
No.
So the early in Ethereum, that just basically the event that caused the split between Ethereum Classic and Ethereum, which was a rogue smart contract, the DAO concept, where somebody found, I forget the technical term for it, but a way to stop execution in a way that removed the funds without the contract being aware of it, and so just kept this
It was
going.
fully aware of it, and it was doing what it was for.
Well, yeah, the code did exactly what it should
It was
have.
a
Yeah.
re-entrancy bug.
Yeah.
Just this loop of state was getting changed at the wrong point, and they were re-entering the contract, and what was saying do you have enough account balance?
Not reducing.
You don't, then we're not going to allow you to do this. Well, they should have updated the account balance before the transfer occurred. It was basically 2 lines of code that just cost a few $1 million.
Yeah, few.
Few cents.
And,
I mean, in today's Ethereum price is a few $1 billion.
Yeah.
I think the parity hack is even more simple though.
Yeah, the parity hack was a little bit more painful, and that comes down to just the language design choices in the platforms.
And that's the next thing to sort of talk about. Solidity is the language of the EVM. You're working on bringing x86, could be C++, Go.
When it kills Solidity.
Yeah, and there's a lot of money transferring. Are we required to audit anything that has money now? Is that just a default? Or how do we build these contracts with confidence that we're not going to be the next re-entry?
Well, I think I think and I hope that the market will kind of incentivize bringing security experts and language experts into the space to say hey, I'm providing my services for you as a consultant to actually audit your contract before you go to production. And I think it will just hopefully put more pressure onto the developers themselves who are making those contracts to have a more prudent engineering culture and not treat it just as I'm spinning up an AWS server and just running some app that I downloaded last weekend and was playing with, right? We have to think about how we're using this technology and approach it carefully. And there's always going to be a way for someone to put a bug into the system, intentionally or unintentionally. So I think that it's going to require more awareness around those issues, and then building up that culture around formal verification and understanding the system that you're working in.
Yeah, the semantics are. I'm really excited to see what languages and paradigms come out of programming on blockchains, because it's this whole new paradigm available to developers, where you have these problems in the real world that are being solved by creating new languages, new abstractions, new semantics, where, say, the telecom industry uses, they created Erlang to create very fault-tolerant, concurrent programming language, and it's baked right into the language.
I personally think we can, draw from some of the time that has been spent in the past, creating these secure languages and stuff what was it? Ada is used by the military for their life critical type stuff and all that,
Nuclear.
and then Erlang for telecom and all that.
And there's
then you have a pool of knowledgeable people who work in those languages.
Yeah.
So getting them onto a blockchain ecosystem is no problem for them.
Yeah, Philip Wadler, one of the creators of Haskell, is working on a smart contracting programming language, and Haskell is known for some really nice type safety features. And RChain, the creators of RChain are also working in functional languages, but they're looking into something called the Pi calculus, which is crazy, and they're creating this really interesting language for smart contracts that is just a whole new paradigm, and I'm really excited to see if these new paradigms of programming that are specific to smart contract programming.
Sure. It'll be really interesting to see how that turns out.
Yeah.
Because I think one of the biggest problems in blockchain is everyone wants to invent their own thing.
Yeah.
No one wants to draw from the past and experience and see what has broken before them.
I don't know.
They just want to invent their own thing because it's never been broken because I just invented it.
Yeah. I mean, you have the Philip Wadler, and you have people basing their languages off kind of ML style languages and the Lambda calculus and the Pi calculus. These are things that have been around for decades. And so I wouldn't say
for sure
everyone's inventing new stuff, but
there's a lot of people.
We
though.
did, we did. But we did get in the situation with Solidity where they, just like JavaScript, they wanted to create a language that looked nice, that looked familiar, and that developers would use. And if you created a language for smart contracts that looked like Haskell right out of the gate, no one would use your platform because it's just.
But now now that's kind of out of the box though.
Yeah.
Now we know we kind of need something like that that's secure and it's hard to make a bug in.
Yeah.
The last.
Sorry.
We got to wrap up. So last thing before we close, what do you do when you have a compromised contract? How do you get people to stop using that contract? Is there a way to forward them onto the correct new contract that you put out?
That was my question.
Excellent.
Yeah. Proxy contracts, ways to put logic in your contract where you can have shut off valves. Ways to keep it from the contract having a full owner, but still having the ability to.
That's kind of where, I think having a governance system available for these smart contracts would be extremely useful.
Yeah.
Having a governance system for how to shut it off and how to upgrade it. Because one of the big annoyances I have with EVM is that you can't upgrade contracts in any way. You have to use proxy contracts and other complicated stuff. So in the x86 VM that I'm making, you can upgrade contracts, but of course you would need to have some kind of gate or something over that controls that, and that probably if there's not an actual owner, then you need some kind of governance system where the community and people that are using it can basically say, okay, this needs to be shut off because it's dangerous right now. Later we can upgrade it whenever someone comes forward and people review the code and everything, and it's all good.
Reduces the risk of a hard fork.
Yeah.
Maker has this going on in their DAI stablecoin right now, where they have plans to upgrade it into a new version of the stablecoin that supports more collateral, but they baked it in with these multi-sigs and governance. It's really interesting.
Yeah, I mean, for me, it brings up interesting philosophical things about immutability, right? I mean, if the whole code is law meme, I mean, I don't necessarily agree that needs to be the standard, but at what point do you decide what are we going to change for users? Are you going to take just a pure communal social aspect and just make sure that you have enough announcement and that there's kind of this social capital that the developers have built up, that they're trustworthy, and that they're not introducing something that is going to cheat people out of funds or change data underneath, so it's do you just swap code out from underneath your users? I think I guess at the end of the day, it depends on what you're building.
Yeah, and I think you're going to have people in both camps. You've got the Ethereum Classic purists that say, no, the code did exactly what it was supposed to.
Yeah.
Don't fork. This is what should have happened. And then you're going to have the other camp that's the shit camp. Let's fix this. How do we stop it? How do we roll it back?
Yeah.
I'm personally more in the latter. I'm about fixing things and not taking advantage of exploits wherever possible, but I see both sides.
Well, and I think for me, it's kind of changed my thought process about smart contract development. And I think wherever possible, a good kind of paradigm might be trying to create smaller contracts that all kind of come together to build a system. So then when you go perform an action or some like short-lived set of actions, instead of having to replace the entire ecosystem, I can just spin up a new contract that has that code, right? And maybe the user can choose that, right? You can present to the user and say, hey, we added some functionality to this kind of buzzwordy here, but here we go, smart contract microservice, right? that has this new functionality. Like, do you want to use it? You always have the option of deploying the old one, unless maybe there's some critical bug, right? But then in that case, you can just present to the user to say, hey, this one has a bug. Here's the new one. We're going to spin this one up, and then you don't necessarily disrupt the people who were depending on the old system.
Yeah.
But it really depends on the system that you're building. Yeah, and I think at the end of the day, it'd just be you kind of gotta maybe not think so much in the monolithic, like this one contract to rule everything for your entire system, and maybe try to split it up so it's more modular.
And I think there's a lot of learning from the past that we've figured out that that's generally the right way to do most things at scale. All right. We're going to end it there. I wish we had 2 more hours to continue talking about oracles. There's so many other things we can talk on.
Nice.
But I knew time was going to be tight. So thank you guys all for coming, and keep building shit on the blockchain.
Thanks for having me.